All right. So vertical and horizontal parts that make up 2D motion, two-dimensional motion, are called components. So components is a new term that we're going to start using. It just means parts. Components means parts. So you could have an X component, which is going to be parallel to the x-axis, and you have a y component. Remember, the x-axis is side to side, and the y component is going to be parallel to the y-axis, and remember, y is up and down. Okay, so I'm going to write an example problem, and I need you to write it down, and then we're going to talk about it and solve it, okay? It's kind of a large example problem, like there's a lot of writing involved. That's because typically on the test, you'll have word problems and you have to pull that information from there. So I don't want to just throw up a picture and call it. So filming a movie, a plane travels at 95 kilometers per hour at an angle of 20 degrees relative to the ground. Okay, so filming a movie, a plane travels at 95 kilometers per hour at an angle of 20 degrees relative to the ground. A film crew travels on the ground filming the plane above. What velocity must the truck maintain to stay directly below the plane? So we're going to sketch this out. There's my ground. So my plane obviously an airplane. Look, that's where the pilot would sit right there. He would sit right there. My plane is traveling 95 kilometers per hour. At 20 degrees relative to the ground. Yes, I realize that my sketch is off. That it's not a 20-degree angle. I don't teach geometry. This is as good as I got. Okay, wait till y'all see my truck. So I have a truck falling below the plane. It's got the film crew back there filming it. And he wants to stay directly below the plane. How fast does he need to go? So we can break this problem down into vertical and horizontal components. So, and this would be the vertical component. And we're dealing with velocity, 95 kilometers per hour is going to be the velocity. So this would be my velocity in the y direction. And then I have my horizontal component on the ground. You can also look at this like a triangle. So we have my hypotenuse, my x, and my y. So as a triangle, across from that angle is my opposite leg. And next to the angle is my adjacent leg. What I really want to find is my Vx, or my adjacent leg. So I have a formula to do that. I'm going to use cosine of theta is equal to my adjacent over my hypotenuse. Hypotenuse, that has a T in there. But again, what I really want is this adjacent. So I'm going to manipulate my formula algebraically to get so that it's adjacent equals 2, and then what I need to do. So to do that, I need to get rid of my hypotenuse on the bottom. So this would be divided by 1. You'd cross multiply both sides. And I'd get my adjacent leg is equal to my cosine of theta times my hypotenuse. But really, my adjacent leg is V of x. So plugging in what I know, V of x is equal to the cosine of 20 times 95. So I do 20, close my parentheses, times 95. So v of x, my velocity that the truck has to maintain, is 89.3 kilometers per hour. Okay, for some people, they don't trust. So 20, I can also put my times in. It's the same thing, right? Parentheses means to multiply things like that. So either way, it's up to what you're comfortable with that. For this particular problem, I don't need to find my vertical component, my velocity in the y direction. But if I needed to, you would use the sine of theta is equal to the opposite over the hypotenuse. And I would rearrange that again, putting this over 1, cross multiply, to get my opposite leg is equal to my sine of theta times my hypotenuse. Remember, with that opposite leg really being motion in the y direction. I know this is a lot. This is trig. It is not easy. We're going to work through this. We're going to do another problem for an example. So we are going to find the vertical and horizontal components of a helicopter traveling 95 kilometers per hour at an angle of 35 degrees relative to the ground. So it's very similar. All right, so again, we're going to sketch this out because with vectors, I'm expecting you to draw it out every time. I don't care how good you get at vectors, you need to provide a sketch. So my helicopter is going 95 kilometers per hour. I have my ground. Here I have a theta of 30 degrees. And I want to know my vertical components and my horizontal. Sorry, this should be next. So to find my vertical, I would, why do I always leave that off? The sine of theta times the hypotenuse. Plug it in what I know, be the sine of 30 times 95. Helpful if you could see the top of the calculator. So sine of 30 times 95. Was it 30 or 35? I said 30, okay. would be 47.5. And my x must be cosine of theta times that resultant, or the hypotenuse, which would be cosine of 30 times 95. It's not meters, I'm sorry, it's kilometers per hour. Kilometers per hour. That is the horizontal, I did vertical and horizontal components of my helicopter movements.
How do you know
So the hard part about vectors is identifying where your angle theta is. Once you have theta, you know that this next, put it on the screen there. Once you have theta labeled, you use your adjacent is next to it and your opposite is across. So the hard part about vectors is actually doing your sketch correctly so that theta is labeled correctly. Once you do that, you want to find opposite, you're going to use sine. You want to find next to, you're going to use cosine.